Okay, I'm going to go ahead and start a little bit. All I did at this point was just create a directory with a go mod init file. So let me show you how to do that from the command line. So I changed to my get going directory, and all I did was make dir get going 09. Well, that already exists. That's fine. And then I changed into that directory. And ran mod init github dart get going 09, and that created my modules file. And excuse me, and that just makes my life easier for something. So let's actually really get going in just a second here. But I just wanted to cover that again. All right, let's go ahead and quit out of that. So let's go ahead and create our main file. And generally, I name it the same as the folder it's in. And this will be another package main. So let's create a func called main. And as a general rule of thumb, I still, in this day and age, still like to just run a hello world just to make sure everything's okay. Okay. And so if we open up a new terminal, there we go. Okay, so everything's fine. Now, as I promised last time, we're going to do something real. And the thing we're going to do that's real is we're going to respond to a web request. So what's a web request? Web request is simple. When you open up a browser and you start a web request, you open up a network connection, and on that network connection, your browser begins by writing the following line. So if you were to say open up google.com, so we can go ahead and do that. New window, google.com. Okay, so what happens when we did that? So the first thing we did was we wrote we connected to the Google servers. We wrote a line that said get HTTP 1.1. Then we wrote some headers. And since this is HTTP 1.1, we wrote host, google.com. And I don't know if we wrote anything after that, but probably an accept line that said we accept text HTML MIME type. And let's leave it for that. We wrote a blank line, and then we had no message body. But if we were doing if we were going back to the Google example, we go ahead and enter a search term in, we send a slightly different request where we include a message body, which is our search term, which would be something like search or q equals, and then something like that. Anyway, that is essentially a web request. You can learn more about it on any number of sites that will walk you through what is, and there is a lot of stuff I glossed over completely. But that's what we're going to do today. We're going to create a server that responds to a web request. And when the server responds, it can respond with anything. It just has to tell you what it's responding with. So in some cases, when we, say for example, let's go back to Google. So we go to google.com. And when we made our request, google.com responded with a whole bunch of stuff. And in fact, we can go take a look at view. Oh, I haven't turned off developer. Anyway, long story short, it responded with a whole bunch of stuff. The page body, then the style sheet that makes the page look the way it does, and also images that make the, for example, let's go back to our search for salamanders. We see salamanders, we see images, and that's binary data. All right. All right. So anyway, let's start by looking at let's start by golang.org. We're going to start looking at packages. And what package do we use for this? We use the net package, right? I said that basically an HTTP request is a special kind of protocol over a network connection that we establish with a server. The network connection is kind of generic, and you could do different protocols over the network connection, but in this case we're going to do a HTTP protocol, which is which is what the web runs on. And so we're going to take a look at the HTTP package. So if we do, let's go ahead and just throw this in here. And so if you need to read about any of this stuff, you can definitely read about it here. And specifically, we're going to use the listen and serve method. And if we look at the listen and serve method, yeah, that's right. It is going to start listening to incoming network connections. Now, if the network connection is okay, it's going to start listening to network connection, but how does it know what to do? Well, that's because we're going to implement an HTTP handler, and we are going to register that handler. So there is the handle function that we're going to call, and we are going to give it a string, which is a document we're going to match. So if I were going to give another example with Google, well, actually let's not use Google. I don't know, let's use, let's go back to Google. So let's say salamanders, and let's say I click on one of these links. So if we go up to the address bar, that is, this part in here is what we're going to be using for the path. So we're going to say that anytime, for example, that you get a request for wiki salamander, you respond back with a salamander page. Okay. And we are going to respond to two different endpoints. We're going to respond to, and we're going to send back the index, and we are going to do two things. We're going to send back an index when the person requests for a slash, and when someone asks for slash hello, we're going to say hello, and if they pass us a name, we're going to give them back their name. So first, what does a handler look like? Well, it is something that that satisfies the handler interface. So as we've discussed previously, you satisfy the handler interface by implementing the serve HTTP method for your type. So we're going to do the most straightforward, which is type index and make that struct, and it's going to be empty because there's no data, there's nothing that we need in the struct right now. We are going to implement the handle interface, so we're going to say func I index, because it's a method on index, serve HTTP, and the method, if we go back to here, takes a response writer and a request. The response writer is how we start sending back data from the server. So as I talked about in the protocol, the web browser sends a request. That request has a header, it has a request line, it has some headers, and then maybe a body. Well, the server comes back and starts writing a response. It writes a it writes the request status line, any additional headers it might have, and then whatever data it's sending as a response body. So we're going to start by, and typically the response writer is W, and it's in the HTTP package, response writer. And the second parameter is a reference to the request. And the request has a lot of information about the request. So, okay, so now we're going to take our, and they are, pretty much historically use W and R for these. And it returns nothing. So there's no nothing to return. It doesn't even return an error. And what we're going to do is write, and we're going to write hello, or we're going to write this is the index. Now you'll notice I get a red squiggly because we can't write a straight string. The write method takes a slice of bytes. So we've got to convert the string to a slice of bytes. So that implements our handler. Now we need to register our handler. So we're going to register our handler by saying handle. And we're going to, this is the root, the home page, right? The index. So it's the leading slash. And then we're going to give it an incidence of I, or we're going to give it an instance of index. Okay, so we've given it an instance of index. Now we can just call HTTP listen and serve. Now the address. So when you contact google.com, what you're doing is you're opening up a network connection to the address of that server on a port. A port allows a given server to handle multiple different applications that could be receiving data. For example, a server could be both a web server and a mail server. And to distinguish between which service gets some data, the mail service and the web service listen on different ports. Um, if you connect to that server and you connect on the email port and try to send it a web request, it won't know what to do with it. Likewise, if you connect to that server on the web port and you try to send an email request, it won't know what to do with it. So the address we're going to give it is a little different than other internet addresses. We're just going to say colon 5050. So this is saying anything listening on 5050, port 5050 on this machine, this will respond to it. Or sorry, this will listen on port 5050 on this machine for any requests and respond to them. We're going to pass nil for the second thing because we're using the built-in we're using the built-in request multiplexer to register a request, but we could have passed it an instance of index here. But since we're going to register multiple of these and using the built-in multiplexer, we're just going to go ahead and send nil here. Okay. So now I can go ahead and go run this. Nothing happens, so nothing's happening down here, but let's go to our web browser and we will go and we see our message. This is the index. Okay, great. So let's stop this. We'll just use Control-C to stop it. And we'll add another one. So if you'll notice, I didn't use any fields for this inside of our index. I could have made this literally anything, right? I could have said it's a kind of int. And if I go run this again, oh, there we go. So if I go run this again, and let's reload it. Yep, works fine. So we use the struct, but we don't have to. Oh, I need to give it a struct body. Okay. So now we're going to do another responder, and this is going to be our name responder. And so we're going to create. Let's call it hello or hello. One of the three hardest problems in computer science is naming things. Okay. So same deal. We're going to go ahead and implement the handler method or the handler struct interface for this for the hello struct. And it takes the usual response writer, and we get the request, right? Okay. Oops. My bad. And it's very common in Go to just use a single character, just a couple of characters for this. You'll find that a lot of times in Go, people will be very brief if it's very clear what what value they're dealing with. In this case, what we're going to do is we're going to so we're going to have a response, and we're going to say that's fumped s printf hello, and we need to get the name. So how do we get the name? Well, when you send a request, there are a couple of different ways you can send stuff. One is in the body of the request, and the second way is in the URL. So I don't know if you've ever seen URLs, but sometimes you have URLs that, let's see if that does it. Yes, here we go. So you have a specific page. Oops. You have a specific page, which is w index.php. So that is the URL you're going to. That is the what we pass in to tell the handler what page we're creating a handler for. Or we tell the multiplexer which page we're creating a handler for. Then you've got this question mark, and then you've got some key value parameters. So you've got the question mark, then you've got a name like action or title, and a value like salamander or edit. And they're separated by this ampersand. So that is how we're going to get this stuff. Now it's been a hot minute since I've done this, but quest dot quest.url, and it's query that returns back the query. That's that part where we had the name value pairs. So Q so get returns a string. It gets the first value associated with, if there are no values, it returns the empty string. And it returns them back as a URL values. So let's take a look at a URL values. Oh, I'm sorry, it returns back a string. It's a method on URL values, so it returns back a string. So we'll say name equals name. And that's what we can fill it down here, right? And now we just got to send the out response out to this response writer. So we are going to write, and again, it doesn't understand strings, so we have to send arrays of bytes, and Go has a very nice way of turning any string into an array of bytes, or a slice of bytes, I should say. All right, so if we run this now, so let's stop and restart it. If we run this now, oh, we didn't add it as a handler. So let's HTTP handle hello and hello. Okay. Let's go ahead. There we go. So let's go ahead and check that. Okay, our index still works. And so now if we say hello, and it was a lowercase h, right? Yeah, lowercase h. So we have a question mark, name equals Joe. Hello, Joe. All right, what happens if they don't pass in a name? What happens if somebody is just not compliant and they refuse to pass in a name? So let's take that out. We just get hello. And that's because as get promised, it returns back an empty string. So when we look for name, name isn't part of the query. So this becomes an empty string. Well, we could handle that, right? So in this case, it's perfectly reasonable to anticipate that someone may not add a name in and deal with it appropriately. So we could say if name is the empty string, we could set name equal to uh, whoever you are. So now let's go ahead and stop it. And if we go back to this, hello, whoever you are. And if we say name equals Joe, we get hello Joe. Fantastic. Okay, well, we got 5 minutes here, and we've covered the meat of what I wanted to cover. And note that even though I've been programming in Go for a bit, and I do some Go at work, I don't memorize every API, and it is perfectly reasonable to just work through an API like I did. If you don't remember it off the top of your head, it's fine. That's not what makes you a good developer, is memorizing every single API. What makes you a good developer is kind of understanding the basic concepts, kind of understanding the underlying technology, and being able to combine them in interesting ways. So I will cover one more way to handle a request, and that is just creating a function. And we are going to call this function my handler. And it takes HTTP response writer and a request. And what do we want it to do? We want it to say w.writeHeader. And again, we're going to be sending back bytes. So I'm just a function. What's the issue here? So let's. Oh, we write header. So write header is what allows us to communicate some other information to the requester, like whether or not there was an error in the request. So I have, I'm just going to say I'm just a function. And down here we've got handle, which is what we used before. We can also use handle func. And we're going to call this func. And we're going to pass my handler. All right. So with that, we're going to hit stop this. And we are going to go to func. All right. And we get that. I am just a function. So there. How does this magic happen, by the way? Since I got a couple more minutes, essentially there is a type called handler func. So anything that is a response writer and a request, any function that takes these parameters is a type of handler func, and handler func implements serve HTTP. So anytime you define a function that takes these two parameters, it will be able to handle its own request in a weird way. Yes, so we covered the basics of what a web request is, right? It's a network connection to a server on a port where we send back some information, and we're sending the request the request line. So we're saying we're going to get, and for example, in this case, we're going to get, and then we have to provide an HTTP protocol number, always using 1.1. Then some headers. And that's it for a simple GET request. And the server is going to respond with OK. I believe it's the document that we requested, but the server is going to send its response, and we can actually, the server is going to send back its response, and that's the part we wrote in here. And in this case, we actually read one of the query parameters off. So we can go to hello. We read one of the query parameters off to say hello to a specific person. And we also handled the case where they might not have sent in a name, and we want to recover from that gracefully. All right, that is it for today. And like I said, today I wanted to do something useful besides just going over aspects of the language, or aspects of the, well, really aspects of the language. All right, we'll see you Tuesday.